Since we have chosen Rajshahi as the model city for the project, let's jump onto the map of Rajshahi. As we can see on the map, the locations of the wards are denoted, where water from the Podda River is to be supplied. First of all, surface water will be collected from the river with the help of a small portable reciprocating pump. Then the water will be transported to a source tank where the water will be stored. From the source tank, untreated water will go through electrocoagulation, solid separation, and ultra-nanofiltration processes respectively. Untreated water enters into the electrocoagulation cells at first. So in EC cell, water is hydrolyzed into hydrogen gas and hydroxyl groups on the surface of the cathode. Secondly, a metal ion is driven into the water on the surface of the anode. Thirdly, electrons flow freely from the cathode to the anode, which destabilizes surface charges on suspended solids and emulsified oils. As the reaction begins, metal ions form complex ions with hydroxyl groups and create large flocks that include metals and other contaminants. Suspended solids and emulsified oils are radially entrained within the flock because of the destabilized surface charges. Finally, the hydrogen gas bubbles help to separate and leave the flocks. These cooperative reactions are what make the EC process so effective and efficient. As water leaves the EC system, it enters into a settling tank. Here, the effects of the EC reaction are further accelerated. The flocks generated during the EC process begin to react with each other and form larger flocks that can float or settle out of the water column. Finally, water leaves the tank and is directed to the filtration system. Then the process of ultra-nanofiltration begins. The system consists of a logic controller, an integrated pump, guard strainer, an air blower, backflush pump, and an ultra-nano membrane. As water enters the ultra-nanofiltration system, it passes through a pair of pre-treatment guard strainer to remove sharp objects. After passing through the guard strainer, the water is dispersed through a manifold of UF membrane. Differential pressure forces water and particles smaller than 0.1 microns through holes in the membrane fiber to the inner core. Another differential pressure is created, this time separating the particles which are even less than 0.1 microns in size. This filtered water can then be discharged or sent to additional processes. Suspended solids and other contaminants, including bacteria, protein, or viruses, are filtered out through the membrane fiber outer core. As contaminants build up on the outer core, a cleaning cycle is activated with pressurized air and backflushing with treated water to keep the UF and NF membrane clean. Here we can see contaminants are being flushed out as water is flowing backwardly. Water with 99.99% purity is the final product. Then the pure water will be stored in the reservoir and supplied throughout a certain ward, providing an easy solution to meet up the scarcity of pure drinking water. Here we can see the usage of pure water ensured by Smartreat. Therefore, some key features of our project are usage of solar energy in electrocoagulation to achieve SDG, application of ultrafiltration and nanofiltration technology to obtain 99.99% purity of water, cost reduction at a decent scale by using PEX pipe. Last but not the least, Smartreat, a packaged water treatment plant, will be the efficient one to ensure safe water demand widely. Smartreat, purity in each drop.